Look at this simulation of a perfectly flat geometric landscape. When generative content reaches this level of grammatical perfection, search algorithms struggle to find any unique data points to anchor to, often resulting in a total loss of visibility. In advanced search ecosystems, this state of infinite digital smoothness is processed as low information density noise. The current industry response is to solve this invisibility by prompting models to humanize text. Agencies are spending thousands trying to force AI to write more, assuming that higher word counts equate to higher value. The data suggests this approach is failing. Adding more words to a prompt typically results in a much larger volume of completely structurally homogeneous text. Structural homogeneity occurs when writing lacks deviation, friction, or unexpected syntax. Every sentence resolves exactly as a mathematical model predicts. Modern search algorithms are increasingly optimized to scan for friction rather than raw word count or keyword density. Surviving the 2026 search landscape requires a shift toward intentional friction. We call this brutalist SEO. To rank in a saturated index, content requires deliberate structural imperfection. By utilizing unconventional architecture and abrasive metadata, you introduce brutalist elements that function as unique signatures within the code. These signatures provide a form of human proof, a signal that distinguishes the content from the generative baseline. Excessive word count is an illusion of quality. True algorithmic visibility requires engineering structural deviation from the machine standard. Watch how LLMs construct sentences by calculating probabilistic word choices. It locks in the median probability, plotting every word at the peak center of a statistical bell curve. This mathematically flawless text condenses into a frictionless block of data, the median baseline. Contrast this statistical median with the functional requirements of a search engine index. Search engines exist to rank distinct informational value. They are not designed to reward average probability. When search crawlers encounter this predictable, flawless text, they process it for computational efficiency. Content representing the exact statistical median of the algorithm's own training data is frequently categorized as baseline noise. Because the text lacks standard deviations, it offers no distinct data points to prioritize. As a direct result, it becomes completely invisible within the search index. Human editors often exacerbate this by polishing AI drafts, stripping away unique quirks or formatting. This relentless pursuit of editorial perfection is what actively destroys ranking potential. Grammatical and probabilistic smoothness equate to algorithmic invisibility. If a machine can perfectly predict your next sentence, a search engine has no reason to index it. The necessary counter-strategy is structural entropy. You must intentionally break the baseline noise. This mirrors modern architecture. On the left, a featureless glass skyscraper. On the right, a brutalist concrete building with exposed beams and sharp asymmetrical angles. The glass building represents standard AI token generation, frictionless, predictable, and devoid of individual character. The brutalist building represents high-entropy content, exposing its structure through abrasive hooks and opinionated transitions. High-entropy content uses unconventional structural formatting and abrupt logic jumps, rather than introducing spelling errors. These deliberate imperfections create a non-linear logic that predictive models are designed to avoid. Search algorithms read these jarring shifts as abrasive heuristics. These heuristics function as a signal. They indicate to the indexing algorithm that a human engineer made non-median choices. Perfection is a hallmark of automation. Structural grit and deliberate imperfection provide algorithmic signals of human curation. Transitioning to this model requires a complete restructuring of your metadata architecture. Avoid using an LLM to generate title tags or H1 headers. Standard AI-generated headers default to smooth, highly expected syntax patterns, designed to satisfy the broadest possible query with the least amount of friction. Look at this code inspector analyzing a standard metadata title. When a phrase like "top 10 tips for SEO strategies" is processed through a syntax tree, the branches are perfectly symmetrical. The system flags this as low complexity. A crawler parses this expected syntax instantly and categorizes it as low-value median data. Now look at the brutalist alternative. A title like "Your SEO is too smooth and it's killing you" produces an asymmetrical syntax tree. The lines are jagged and interrupted, registering as high complexity. This interrupted syntax forces the algorithm to spend more computational energy parsing the string. This minor computational snag is a high signal event. It disrupts the automated parsing process and triggers a higher prioritization within the index. Build chaotic headers that intentionally interrupt both algorithmic parsing and human scrolling patterns. Your SEO architecture must expose its raw structure, rather than hiding behind the smooth formatting of a machine. This topological map represents the search index approaching 2026. The vast terrain is a flat plane. Isolated across it are sharp, jagged peaks glowing with high signal metrics. As flawless sludge expands, it swallows minor variations, leaving only the sharpest peaks untouched and visible. Effective optimization no longer relies on mimicking machine-level grammatical perfection. The primary metric for visibility is establishing a distinct origin through structural grit. Audit your current content pipelines for signs of algorithmic smoothness and predictable transitions. Reconsider strategies that aim to blend in with the median probability curve. Success in the next generation of search requires abrasive, highly structured imperfection. If your content architecture lacks deliberate imperfection, it lacks the necessary signal to survive the coming shift in ranking algorithms.